Hello everyone. Let us solve problem E of AtCoder beginner contest 185. In this problem, you are given two array A and array B, and you can remove as many elements as you want from both the arrays to make their size equal. For example, you can remove element 2 and element 3 from this array, and you can remove this from second array. If you will do this, you will get this. Array A will become 1 and 1. Array B will become 1 and 3. And what is the cost associated with this? The cost is how many places they are not equal in the new array. So here they are equal and here they are not equal. So at one place, plus how many elements you have removed from both the arrays combined. So you have removed 1, 2 and 3. So the cost will become 4. So this was one way to do this. Similarly, you can do this in other way to make their size equal. For example, you can just remove the last element, and if you will do this, you will get two array A and array B. B will be unchanged, 1, 3, 1, but A will become 1, 2, 1. And what is the cost associated with this? Cost associated is how many places they are not equal at one place here, plus how many elements you have removed? 1. So the cost is 2. So in the first way, the cost is 4. If you do like this, the cost is 2. And similarly, there are a lot of ways to do this, right? And what you have to do, you have to find the minimum cost. This is the question. Okay, let us look at it in a generic manner. So you have an array A, an array B, and it say array A has elements from index 0 till I, and B has elements from index 0 till j. So in the optimal solution, or you can say the optimal solution can be obtained by doing one of the following thing. The first is the ith element of A. The ith element of A will not appear in the optimal answer. Or the jth element of B will not appear in the optimal answer. Or the ith element of A and jth element of B both will appear in the optimal answer. So these are the three scenarios. And let us represent the cost associated with these two arrays, in which array A has element till I and B has starting from 0 till j. Let us denote cost by I comma j. I for array A and j for array B, right? Okay. And what will be the cost of this sub problem? So we know that we are removing the ith element, or the ith element will not come in the optimal answer. So the cost will be 1 because we are rejecting this element, plus what is the cost of remaining. So in the first array A we have I minus 1, and in the array B everything is left. Similarly, if we look at this, what is the cost associated? So we are removing this element, so 1 will come from there, and similarly we can write I comma j minus 1, right? And for the last case, since we are keeping both ith and jth element, so cost will be cost whatever is coming from I minus 1 and j minus 1, plus it can be 0 or 1, both are possible. It will depend upon the value ai and bj. So if ai and bj are equal, right, so we are okay, there is no cost associated. If they are not equal, then 1 will come as a cost, 1 will be added to this part, right? Okay, so let us call this u, let us call this value as v, and the last one as w, right? So which one should we take, which path should we take, this one, or this one? So we'll take the minimum of these three, right? So you can say the cost of ij, which is the main problem that we're solving, right? Cost of ij, we'll say it is minimum of all the possible scenarios, u, v, or w. We will take the minimum, and this will be the cost, right? And in our problem, we have array A with size n and array B with size m. So what we want to find? We want to find the cost. What is the index of last element of A? N minus 1. Last element of B? M minus 1. Right. So we want to find this thing, right? And we are done. And now we know how to find this, using how to find some I comma j using some smaller values, like using I minus 1 j or ij minus 1, I minus 1 j minus 1. So we can find u, v, w and take the minimum. Yeah, now we can look at the code, and I will keep this on the side for the reference. Okay, so in the code, first three line we are taking input, we are taking array A and array B and their size, right? And as I mentioned over here, what is our objective? Our objective is to find this cost n minus 1, m minus 1. So that's what we are doing here, cost n minus 1, m minus 1. Let us look at this function cost. So in this cost function, for now, let's forget about these 4 lines here. Let us look from here. So from cost I comma j, you can go to this cost I minus 1 comma j plus 1, which is this scenario, the first one that I have mentioned here. Similarly, you can go here I comma j minus 1 plus 1, which is the second scenario. And the third scenario is this one, cost I minus 1 j minus 1, and we'll take 0 or 1 depending upon ai and bj are equal or not. And then we will return the minimum of, as I mentioned, minimum of u, v and w. Minimum of u, v and w will return. Okay. Yeah. Now let us look at this part, this dpij. So we are storing the result so that we don't have to do the same computation again and again. So in future, if we encounter same I and j, and we have already calculated the answer, then we will return the answer instead of doing these three things again. Okay. So this part is covered now. Now let us look at the base cases. Okay. So the first base case is, so your array A and array B both are empty. So if they are empty, so they are already of equal size and you don't have any element to remove or any element to compare. So the cost associated will be 0. So that's what the first line is. If your both array are empty, then the cost is 0. Now, second is array A is empty, but array B is not. Array B has some values 0, 1, 2 till j. Right. So your array A is empty and array B has element from index 0 to j. But what is our objective? Objective is to make their size equal, and there is only one way to make their size equal. You will have to remove all these elements. All these elements we need to remove. And how many elements they are? From 0 to j, they are j plus 1 element, right? So we'll have to remove j plus 1 to make their size equal. So in the next line, we are returning this j plus 1, right? And similarly, if B is empty and A is not empty and you have element till I, then how many elements you will have to remove, or what will be the cost to make the size equal? I plus 1, right? So that's what last statement is. Yeah. That's it for this video. Thank you for watching.